You hear about all sorts of rare and expensive things, but a chicken that can cost upwards of $6,000.
Wow, 6,000.
Yeah, the Ayam Cemani from Indonesia. They actually call it the Lamborghini of chickens.
The Lamborghini of chickens. I like that.
Right. And even its eggs apparently can go for like 16 bucks each.
$16 an egg.
Yeah.
Okay, that tells you straight away there's something really different about this bird.
Absolutely. And that's exactly what we're digging into today. We want to unpack the science, what makes this chicken so unique, especially its incredible all black look.
Yeah, that look is striking.
So consider this your shortcut, your quick guide to understanding the Ayam Samani's key features without needing a biology degree.
And when we say all black, we really mean all black, don't we? It's not just a surface thing.
Not at all. And this is where it gets really fascinating. The Ayam Samani's blackness, it's not just feathers, it's the beak, the bones.
Bones, too.
Even the flesh is black, which historically you can imagine gave it this kind of mystical air back in Java.
Right. Used in ceremonies and things.
Exactly. Believed to bring good luck, ward off evil, that sort of thing, because it looked so otherworldly.
That makes sense. That connection really highlights how unusual the trait is. Okay, so let's get into the science. What actually causes this?
Right, the biology. It comes down to a condition called fibromelanosis.
Fibromelanosis.
Okay, yeah, bit of a mouthful, but essentially it's a genetic mutation. That's what's responsible for all this black pigment everywhere in the chicken.
A genetic mutation. So something in its DNA. The actual instructions for building the chicken.
Precisely. It's basically a rearrangement within the DNA code that happens when it's being copied.
Like a typo, but maybe more like cutting and pasting a sentence into the wrong paragraph.
That's a good way to put it. A section of the genetic recipe for color got moved or duplicated, and that seemingly small change has this huge knock-on effect on the proteins.
Proteins being the sort of molecular machines doing all the work in the cells.
Exactly. They're built using the DNA instructions, so change the instructions, you change the machines.
And do we know which part of the DNA recipe got rearranged? The specific gene?
We do. It's a gene called endothelin 3. EDN3 for short.
EDN3, okay.
So genes, they hold the blueprint. And normally EDN3 has a job controlling skin color. It manages the production of cells called melanoblasts.
Melanoblasts, those are the pigment-producing cells, right? They give color to feathers, skin.
That's them. In a typical chicken, EDN3 makes sure these melanoblasts are produced in the right places at the right times.
But I'm guessing in the Ayam Cemani, something's different with EDN3.
Totally different. The mutation causes almost all the cells in the Ayam Cemani embryo to start churning out EDN3.
Whoa, all of them.
Pretty much. And this leads to a massive surge in those pigment cells. The melanoblasts may be up to 10 times more than usual, spreading everywhere.
10 times. Okay, that explains why it's not just skin deep. It's systemic. The pigment gets everywhere because the signal to make it is everywhere.
Exactly. That single genetic tweak is why this Lamborghini of chickens looks the way it does and, well, costs what it does. It's dramatic.
That is dramatic. So thinking about how scientists figure this out,
Yeah.
the fact that it's so consistently black must have been a big clue, right? Pointing towards genetics.
Absolutely. You see this complete uniform blackness across the birds. It strongly suggests a fundamental genetic cause. Then you compare their DNA to other chickens.
And you look for the differences, which leads you to EDN3.
Right. And what's really kind of mind-blowing is what scientists think about where this mutation came from.
Ah, yes, the origin story. This is fascinating. The current thinking is that this specific rearrangement, it only happened once.
Ever.
Just once. Seriously.
That's the theory. One single genetic event, a unique rearrangement in one bird, a long time ago.
Wow. So every black chicken breed we see today, they all trace back to that one ancestor.
That's the idea. Breeds like the Ayam Cemani, but also others you might have heard of, like the silky.
Oh, yeah, the fluffy ones.
The fluffy ones, exactly.
Yeah.
And others like the Ayam from Vietnam, the Swarthona from Sweden. They all share this trait because they're all descendants from that single bird with the original mutation. That's incredible. One genetic mistake spawning this whole lineage of distinct-looking chickens around the world.
It really shows the power of these genetic changes. And speaking of silkies, you mentioned Marco Polo earlier.
Oh, right. Our source mentioned his observations way back before 1300.
Yeah, he was traveling in China and wrote about chickens that were black all over.
Black all over.
And he said they had hair only, like a cat's fur. Which sounds a lot like silkies, doesn't it?
Totally sounds like silkies. Amazing! So people noticed this genetic quirk centuries ago. It wasn't the Ayam Cemani specifically he saw, but it shows these fibromelanistic chickens have been around for a long time.
Exactly. It underlines that shared history, that common origin stemming from the mutation.
And importantly, does this mutation cause any health problems for the chickens, apart from maybe making them stand out to predators?
Huh. Good point. But no,
Yeah.
apparently not. Fibromelanosis itself doesn't seem to negatively impact their health. They're perfectly healthy chickens,
So it's just a dramatic visual change.
pretty much. And it's actually a really neat example of how these genetic rearrangements can drive evolution, create new traits, new appearances in the animal kingdom.
Yeah, you can see that.
And studying mutations like this one in the Ayam Cemani, it helps us understand the bigger picture, right? How changes in DNA shape the physical characteristics of all living things, including ourselves, potentially.
It really makes you appreciate how complex, but also how sometimes simple the basis for diversity can be. A small DNA shuffle, a massive visual change.
So just to wrap it up neatly, the Ayam Cemani, the Lamborghini of chickens,
Yeah.
owes its incredible all-black appearance, feathers, beak, bones, meat, everything, to this unique genetic mutation.
A mutation causing fibromelanosis.
Right, which basically floods the body with pigment cells, a single genetic event with a really striking outcome.
It's just a fantastic illustration of how genetics works, how it shapes life in surprising ways.
Absolutely. And it kind of leaves you wondering, doesn't it? What other small genetic changes are behind the amazing variety of life we see?
Yeah, what other hidden variations are shaping the natural world in ways we haven't even discovered yet? Makes you think.